Hello engineering students, this is Mr. O again. I'm going to go through question number 4. It's a bit more of a complicated one because there's a lot more forces. So let me jump straight into it. We have a simply supported beam, question 4. On the left hand side is a fixed or pin support. On the right hand side we have a roller support. Obviously the question is asking us to find the reactions and draw a free body diagram to show your understanding. But we have 1, 2, 3, and 4 forces identified here. So what I'm going to do is I'm going to say question 4. Simply supported beams. Okay, so first thing I'm going to do, I'm going to redraw the diagram so that I'll do it pretty quickly. So I'll do a fixed support, a roller support, and my beam. I want to work out how far apart they are from the diagram here, but it looks like there is 4 in the middle, so there'll be 1, 2, 1 pointing upwards from the bottom, and 1 pushing down, and this is 20 kilonewtons, 10 kilonewtons, 4 kilonewtons, and 15 kilonewtons. I've checked to see that all their units are the same, R left and R right. This is a roller. There's going to be a single one we need to find, which is going to be the force on the right hand side, and it's going to be a vertical. This side there is going to be a force vertical on the left, and there's always, we have to, because it's a fixed or pin support, we have to also look for the force on the left, a horizontal. Okay, so we have 4 forces. Let's look at the distances that they're apart. So we have 2.5 meters from the left to the first one. Again, 2.5 meters from the left, which means the second one is 5 meters. We have 1.5 meters. We have again 1.5 meters. And we have 2 meters. There we go, which means what is the total length of this beam? It can be solved pretty quickly, but I'll do it in this way. 2.5 plus 2.5 plus 1.5 plus 1.5 plus 2 is 10. The beam is 10 meters long. 2.5 is 5, 6, 7, 8, 9, 10. That's it. I verified that. So our assumptions are the beam is in equilibrium. Therefore, the sum of the moments of this beam equals 0. Okay, so what does that mean? That means the sum of all the counterclockwise moments equals the sum of all the clockwise moments. Pretty simply, 0 equals positive sum of all the clockwise moments minus sum of all the counterclockwise moments. All the clockwise moments, positive, and when we do our moment calculation, all the counterclockwise moments are that. Also the same when it comes to our vertical and horizontal forces. The sum of the forces downwards should equal the sum of the forces upwards. Okay, and then of course the sum of all the forces to the left should equal the sum of all the forces to the right. That basically then helps us create this. All the forces up and all the forces to the right will be positive, all the forces down and all the forces to the left will be negative. There's our assumptions done. Now I'm going to jump straight into number 2, which is I want to find out what this is, the reaction around R, that force there, the force upwards. Therefore, I'm going to take a start on the left, and I'm going to take moments. Take moments about the reaction, the support on the left, to find the unknown R, and I'm trying to find the force of the right, the vertical. So how do I do that? I state again one of my assumptions. The sum of all the moments around RL, the reactions on the left, should equal 0. Okay? What that means is that the sum of my clockwise, counterclockwise moments will equal the sum of my clockwise moments. I'll take that over to that side. 0 plus all my clockwise moments, the sum of my clockwise moments, minus the sum of all my counterclockwise moments. Now, a moment is the force times the distance. Technically, it's the turning effect. It's the turning effect of the force acting on that body. So, and if I look, there's going to be quite a few that are going to be causing this. If this is a pivot point now, I'm doing a moment around that. What turning force is in effect by all of these forces? There's going to be quite a few. So there's going to be, make a big now square brackets. One, that's going to cause this beam to pivot clockwise. So there's one there, there's the first one. That one there is going to cause it to go clockwise. That one there is not. That's going to cause it to go anti-clockwise or counterclockwise. So it'll be in the negative side. That's going to be causing it to go clockwise. So there's 3 that are going to cause it to go clockwise. So what I'm going to do is I'm going to go force times distance plus force times distance plus force times distance. That one, and that one are going to cause this beam to pivot this way, like that. That force and that force are going to cause this beam to pivot the other way. So minus the counterclockwise. Force times distance plus force times distance. And all of that, the sum of that together is to be negative because it's all counterclockwise and this is all clockwise. So let me break this down. The first force is 20. I've checked kilonewtons, 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 kilonewtons. Everything in this is kilonewtons, which is excellent. So I won't even put the units in there. I'll go 20 times, how far is it from the left? 2.5 meters. 2.5 meters. Plus the next one, 10. That's causing it to go clockwise. 10 times how far is it from the left? The point that we're actually taking the moment from. 2.5 plus 2.5 is 5 meters. Plus, that one's going to go the other way, so I'll leave that one. And I'll go to the next one. That is now 15 down. The force down. And it's 2.5, 2.5, 1.5, 1.5. So that's 5, 8. This is where you're going to be really careful you don't make a mistake with this. Okay, so what I'm going to do now, just bear with me. Okay. Now I'm going to look to see which forces are now going counterclockwise. It's going to be that one, that 4 kilonewtons upwards, but it is 2.5 plus 2.5, it's 5, 6.5 from the left, plus the unknown one that's pushing it up, which is our force of the right vertical, times how far is it? It's 10 meters. It's right at the end, so it's 10. Here's my whole calculation. So now I'm just going to solve them all together. So I'll do this first brackets, all the clockwise motions. So it is 20. Let me do this like that. Brackets. 20 times 2.5, close brackets, plus, open brackets, 10 times 5, close brackets, plus, open brackets, 15 times 8 meters. 220. So I've got plus 220. Technically, kilonewtons per meter. Okay? Minus. And this is 4 times 6.5. So this is 26 plus 10 FRV. If I then multiply that all out, 220 minus 26, because technically there's a 1 here in the front, so multiply that through, so that becomes a negative 26, and I multiply through to that one, so that becomes negative 10 times FRV. Those two add up together, so 226, 220 minus 26, 194, minus 10 FRV. Remember, these are times. I'm going to take this to the other side, so it becomes positive 10 FRV plus 194. I divide through by 10. 194 divided by 10 is 19.4 kilonewtons. So my force upwards is actually 19.4 kilonewtons. Now what I do, instead of doing a moment, I now do vertical and horizontal forces. So straight away, there are no axial loads. If there's no loads at an angle, which will then cause a horizontal force. So the only thing I can see is a normal force, 90 degrees, perpendicular to this beam. 90 degrees, perpendicular, normal force. 90 degrees, normal force. 90 degrees, normal force. 90 degrees, normal force. Therefore, no axial load. Therefore, no axial load. The force on the left horizontal equals 0 kilonewtons. There's nothing. But so that's basically my left hand side equals my right hand side. But I've got nothing, so there isn't. Now, forces vertical. Okay, so my forces, the sum of my forces downwards equals the sum of my forces upwards. Everything is a normal force. Everything, we didn't have to change anything from a axial load and make its equivalent horizontal or vertical force. So I've got all of those. So what I'm going to do is I'm going to just take this over to the other side, and I'm going to go positive all the forces upwards, the sum of, minus all the forces downwards, the sum of. Okay, so let's do that. 0 equals, all my forces upwards. I don't know what this one is. I don't know what force. So all my forces upwards. Force vertical on the left hand side. It's an upward force. I don't know what it is. Okay. That plus what I do know is I've got 4 in kilonewtons, and I know what that is. That is 19.4. I've just proved it there. 19.4 minus all the downwards forces. 20, 10, and 15. 20 plus 10 plus 15 kilonewtons. So the sum of all the forces downwards are subtracted from all the forces upwards. So what have I got? I've got FVL 19.4 plus 4 is 23, yes. Plus 23.4 minus 20 plus 10 is 30, 45, minus 45. So minus 45, FVL plus 23.4 minus 45, or 45, yeah, will give us negative 21.6. I'll take that over to the other side. 21, hope you can still see that. 21.6 kilonewtons. It becomes a positive because it's a negative now, goes to stuff that's positive, which means it's upwards, is what the force vertical left is. And there is my answer. So what I'll do now is to prove that, I do my force diagram. This proves you actually know what you are doing. So the fourth thing is my force diagram. I'll draw my little things like that. My force upwards, what I've just proved, is 21.6 kilonewtons. It's point, not a comma. This one is 19.4 kilonewtons, and my downwards forces are 20 kilonewtons, 10 kilonewtons, up is 4 kilonewtons, and down is 15 kilonewtons, and my cross is 0 kilonewtons because there is no horizontal forces. I can then prove this by adding everything up. 20 plus 10 plus 15 is 45 downwards, and 21.6 plus 4 plus 19.4 is, I was a bit worried it wouldn't be that, 45 upwards. My force is balanced across my question. There's question 4, a little bit more complex, a few more forces, 1, 2, 3, 4 extra forces on that beam, but they were all pretty simple in the sense they were 90 degrees, normal forces, all perpendicular to the beam, so it was pretty simple. I didn't have to work anything out using sine and cos. Hope that helps.